Hello auditors, my name is Isheng. Today we will be solving Ethernaut Coinflip challenge using Brownie Python. Brownie is a Python-based development and testing framework used for smart contracts. It is a good tool to perform smart contract audits or exploits. Okay, I'm going to illustrate using a painting tool. So we have this particular Coinflip contract. So basically this is our Coinflip contract. So whatever over here will be inside this Coinflip contract. And we have now a attacker contract, which this attacker contract have this function flipped. And this particular function act as a proxy by whenever you call, before you call the transaction in the Coinflip contract, we will first actually run this particular function and calculate the site, which is either true or false, and then send it into our Coinflip contract. So why this work is that because one transaction in this timeline, first thing we actually calculate our own site, and then we will actually send it into our coin. So this is considered one transaction, and this transaction is the same, will have the same blocked hash of the previous blocked. So basically we have the same previous block value, and whenever you calculate it, it will always give you the correct site over here at A, and then we can send it into the coin contract in that particular one transaction. Thus, you will always get the same consecutive win. So we can actually solve this by doing it 10 times and then get a consecutive wins of 10 times. Okay, so now I'm gonna start up my console. Okay, my terminal is on. So basically you can go to our desktop and create a directory which I've already created. So I'll just cd into our Coinflip. And then you can run this brownie init command to initialize the directory. You can see that this directory is the brownie directory that was initialized using brownie init. So just let me open Visual Studio Code. Okay. So over here we have our attacker contract. So as I said, we literally mimic this function, this whole function, and then we'll get the interface of the Coinflip contract, which is over here, to interact with Coinflip contract. So whenever we get the correct site, which will always be true or false, and then immediately pass it into the interface, which interact with Coinflip contract, and then we will always win one consecutive round. So basically we have to run this 10 times. So I will explain the Brownie framework. Over here, we have this network.priority fee which pays 20 Wei, so that this ensures that our transaction run faster. So assuming that you do not have enough test ether, we can just remove this. But we just leave it here for now. So okay, so we get the contract instance from Ethernaut. I just copy paste it here, and then we get the player address in our brownie.config file, which instructs the Brownie to get our private key from our env file. Okay, then we deploy the attacker contract, and then we get our attacker contract address. Okay, just to know that our address is there. And then we have our Coinflip interface. We have to pass in our Ethernaut instance, so that we know what interface we are interacting with, what type of which contract that was deployed before, and what function we would like to use. So in our interface over here, we just want to interact with flipped. And then we also have our consecutive wins over here, so that we know how much win do we get for that turn round. Oh yeah, remember to actually put view so that we can always get our integer, our uin integer that it is 1, 2, or 3. If you never put view, you actually return us a transaction, and when you read it, you will not read the uint number. So what we do now is basically run this script. So you can do it by using Brownie, run scripts / deploy coinflip network Gorally. So I'm just gonna let this run. Okay, the block has been mined 10 times. You can see our transactions. So our consecutive wins is 1. And you can see that this OX with multiple 0. One of the reasons is because coin flipped as a uint 256, basically have 256 bytes. And we get 1, 2, and all the way we got A. So what A means in hexadecimal is 10. And this concludes our challenge. So basically now we have to submit this and win this challenge. Come on, MetaMask. Okay, let's go. So we have sent the transaction. Now we are waiting for it to be mined. Okay, the block has been mined. The transaction has been mined, and we have successfully completed this challenge. If you guys love this Ethernaut Coinflip challenge using Python Brownie, please hit the subscribe button and the like button. Thank you very much and have a nice day.